Well, good afternoon, everyone. Wanted to keep on going with our trigonometry radian measures, do a little more practice on some of the other things that we've been doing. Make sure that you guys are good with that. See if I can get our calculator pulled up. We probably don't want to call anyone at the moment. Put that down. See if I can pull up the right one here. I'm trying to pull up your calculator. Um, let's see where it is. There we go. All right. So again, when I pull that calculator up, go to mode. I'm going to be in degree for what I'm doing right now. So just so you're with me, here we go. Okay, so you got a new packet. I sent a new packet to you, posted it in Google Classroom. So I'll be working out of this today. And here we go. All right, so we want to convert degrees to radians and so forth, radians back to degrees. So before we do that, let's do a quick review, make sure that we understand what reference triangles are. We're asking you to name the reference triangle. Let's get a drawing tool up here. Let's see. Let's go about red. I seem to like red. So for our reference angle, well, that was nice. And we were supposed to go to red, but for some reason we went to black. Welcome to my life, right? Okay. All right, there we go. Okay, so for a 30-degree reference angle, hopefully I don't have to do this for every single one, but if I'm here at a 30-degree reference angle, remember that I want to make a little right triangle, so we're going to keep that at 30 degrees. If I go to 135 degrees, so here's my 90, plus I'll need 45 more to make the 135. So that's going to make this one 45 degrees, and there's the reference triangle at 45. If I go to 240, and again, you don't have to draw these little reference triangles if you don't need to. If you are understanding this well enough, you already know, go for it. So I know there's 180, and I know I'm going to need 60 more in order to make my reference. So my reference triangle then that I'll be working with would be 60 degrees. Finally, the 330. So you know the 330 is going to go all the way around until I have 30 degrees left that I need. So my reference triangle that I would be using would be that 30-degree triangle in the fourth quadrant. Next part is asking us to name the exact value of each of the following. So I'm hoping that at this point you've got that unit circle memorized. I know that we haven't done a whole lot with it as far as me being able to evaluate you there, but it is going to be imperative that you learn this for next year. So I'm going to cut this one through the middle at 45 and cut this one through the middle at 45. So if we were in class, this would be the method that I would teach this to you. The next one that I would do would be the 30. So I would come here for the 30. Come on, let's go to green. I would come here to do a 30, and on the other side a 30. And then here I'm going to do the exact same thing. So I've got a 30 degree and a 30 degree. So you don't need anything other than that. Those are the 30 degrees, 45 degrees, and then I'd probably go to blue and we'd put the 60 degree in. So 60 degree here and then 60 degree here. Now each one of those is going to allow us, hopefully, and I can put these in black, I suppose, to fill in that unit circle really quickly. And I usually only fill in the first quadrant because everything else is exactly the same with the signs reversed. So if I do a 30 degree, remember I have a root 3 over 2 and a 1/2. And then I usually jump up to the 60 and I switch those. 1/2, root 3 over 2. So that's the 60. And then the 45 in the middle. Remember that they're exactly the same. Root 2 over 2, root 2 over 2. And there you go. Remember that these are always in the order of cosine theta, sine of theta. And then if you need to define your tangent then of theta, then it's a sine over a cosine. So if you didn't memorize those, you could very quickly calculate those by putting a sine over a cosine. So a half over root 3 over 2 would tell you what your tangent value is as well. So if you wanted to do your tan of each one of these, you are more than welcome to do those as well. So the reason that I need the reference triangle is because if I'm looking at 240 degrees, so here's 180, I know that I'm using a 60 degree reference. So a 60 degree reference is going to tell me then what I'm using. So if I go back to sine, cosine, so remember that it's cosine sine, so the sine of 240 is this one, root 3 over 2. Now, just make sure you know what quadrant you're in. I should probably switch to red. Know which quadrant you're in. Remember that they're all positive in the first. The sine is positive in the second. Tangent is positive is third. And cosine and secant are positive in the fourth. Okay, so we'll fly on through the rest of these pretty quickly. If you could, when they ask for exact value, this is all I need to do is reference that first quadrant. You can remember also that this one is a 0, 1, and this one is a 1, 0. Okay, moving on. So a tan of 315. So 315, if I think about where tan of 315 is, so there's the 270. And if I want to go to 315, remember that I'm going to need to add 45 more degrees in here. So if I'm at a tan of 315, then I'm a root 2 over 2 and a root 2 over 2, which is going to give me a reference of 1. Remember where you are in the quadrants. You are in the fourth quadrant if you're 315 degrees, so you are not a positive 1. You would be a negative 1. So it would be a negative root 2 over 2 and a positive root 2 over 2. So a negative over a positive is going to give me a negative 1 as a reference. Next one, cosecant. A cosecant of 300. So a cosecant of 300, I have to think of where my reference is. So if I need 300 degrees, remember that here's my 270. I need to go 30 more degrees. So I'm really looking at a reference of 60 degrees. So I'm a reference of 60 degrees and I'm in quadrant 4. Cosecant, remember, it's the inverse of your sine. So the sine of 360 degrees, remember, you're just looking at a 60 degree reference. So sine is root 3 over 2, so its inverse would be 2 over root 3. And don't forget, you're in the fourth quadrant now, so you're a negative. So I just need to rationalize that by multiplying by root 3 over root 3. So I'm going to end up with a negative 2 root 3 over 3. Do them as quickly as you'd like. Take a little more time, especially during this e-learning time. And just make sure that you are very good at understanding the references here. Next one, cosine of 495 degrees. Okay, so cosine 495 means that what I've done is I've already gone around the circle once. So there's the 360. So if I subtract my 360, if I can pull my calculator back up, or you don't have to if you don't want to, it's up to you. But I know that what's happened is I've done my 360. So I'm going to do my 495 and I'm going to subtract the 360. And that's going to tell me my reference is 135. Perfect. So if my reference is 135, then that means I have 45 left. So I've spun all the way around and I've spun back to here. So the cosine, I just look at my 45 degree reference for cosine, which is the root 2 over 2. Let's make sure that we did that correctly. So the 135, so so my 135 degrees is the 90 plus the 45 is 135. So then this one is going to be a root 2 over 2 and a root 2 over 2. And if I'm looking for the cosine of 495 degrees, I have to know where I am sitting. So the cosine is sitting in the second quadrant of 495 degrees. And so therefore, Your sign is your positive one, so I know that I have a negative root 2 over 2. All right. Approximations define trigonometric functions of angles that do not lend themselves to exact values. You're going to use your calculator and to find the approximation for sine theta, cosine theta, tan theta. I need to make sure I can use my calculator to do this because there is no cosecant, secant, or cotan key on my calculator. So I need to be able to do these using my calculator as well, something that we did not practice very much in our other section of Unit 3 when we started radians. So let me pull this up if I can get the calculator to come up for us again. I need to show you how to put these on your calculator. Come on, get over here. All right, there we go. All right, so I'm going to clear off what I've got in there right now. And remember, if it's a cosecant, that it's a 1 over a sine. So I'm going to do 1 over the sine of 250 degrees. So moving into my calculator, I just need to do 1 divided by sine of 250 degrees. And I get a negative 1.06. So that's I shouldn't say equal. I should say approximately negative 1.064. We usually go to 3 decimal places. 0.064 is perfect. The next one is your secant. So secant, remember, is 1 over cosine. So I'm going to do 1 over the cosine of 250 degrees. So 1 divided by, in this case, cosine 250 degrees. And enter. I'm going to get approximately negative 2.923. So approximately negative 2.923. Actually, I should go to a 4 here. It's going to take me 3 times to do this. 924. If I round this off, it's a 8 behind it. All right. Last little piece that we need to do then is your cotan. So 1 over a tan of 250. So let's go to 1 divided by tan of 250. And I get a 0.3639, so 0.364. So it's approximately 0.364. All right. Hopefully that went well for you. Let's move our calculator back over here. We'll finish this up pretty quickly with a couple more examples. You can use this information to solve several approximations. Now, this is an interesting thing that I need to work on. So if I'm asking you to find the value of theta, if sine of theta is negative 0.5592, and theta terminates in quadrant 3, and you're only working once around the circle. So that's what that means between 0 degrees and 360 degrees. All right, so the first thing I need to do is I need to figure out, let me clear all this out. I need to figure out what theta is, and then I need to make sure that I match what they've asked me and where it's terminating. I'm going to pull my calculator up. I'm going to do 1 over no, I'm not doing that. I'm looking for the angle, so no inverses. So we'll do second sine. So I want to know what the angle is when it's negative 0.5592. So the angle is a negative 34 degrees. Okay, so if you're a negative 34 degrees, the only thing I have to worry about is that I'm terminating in quadrant 3. So if I'm terminating in quadrant 3, and I'm a negative 34 degrees, that means this is 34 degrees. If I'm in quadrant 3, remember that all students take calc. It just means that I'm in the third quadrant, obviously. But in order for me to get there, I need a reference triangle that has an angle of 34 degrees. So all I'm going to do is take this whole 180 and then add the 34 that I need to get me into the third quadrant. So my angle is the 180 plus the 34, And so that's going to tell me I have what, 214 degrees. So a 214 degree angle is the one that takes me to the third quadrant. I can only go once around the circle. And so there's my limitation. It's telling me where I have to stop the angle at. The next one says, can you find theta if you have a tangent now? Your value of tangent is negative 0.8541. All right, so let's find out what that is first. So we'll go second tan of negative 0.8541. Okay, so it looks like we're at negative 40.5 degrees. So my theta is a negative 40.5 degrees. Now, it tells me that I'm terminating in quadrant 4. All right, so if I terminate in quadrant 4 and I'm at a 40.5 degrees, because again, I'm restricted to once around the circle, it looks like my reference then is going to have to be my 360 that I would have had, and then take away the 40.5 that I didn't quite get there. So if I have a negative 40 degrees, I would have been moving in this direction. So we'll take the 360, we'll take away the 40.5 degrees, and that'll tell me that my theta, so the theta that I'm actually looking for as a reference, is 319.5 degrees. You are in quadrant 4 for this to happen. Okay, and then the last one. So the last one, let me see if I can pull this up again. The last one that we're going to be looking at, this is the sine of theta. It looks like I don't have this. I bet this is a negative 1/2. So I need to find the angle if the sine of the angle is a negative 1/2 and terminates in quadrant 3. Okay. Let's see. Without using my calculator, let's see if I can do that one without using my calculator. I know that I'm going to end in quadrant 3, so I'm over here. And I know that I should have quadrant 3. So if I have a half and I'm sitting in quadrant 3, it looks like I should have a 60-degree angle that I'm using. So if I'm using a 60-degree angle, I need the 1/2. I'm sorry, that's not true. I would have the 30-degree angle. So the 30-degree angle would give me this ordered pair. Root 3 over 2, 1/2. If this is my 30-degree reference, and if I'm in quadrant 3, and this is my sine, it tells me it's negative. It's a negative 1/2, which is what they told me that I had. So what that tells me is I had to do the whole 180 plus the 30 more to get me to a negative 1/2 for my sine. So therefore, you can use your calculator if you like. If we were in person, you would be doing this without a calculator. So what that means, if you've got to take your 180 degrees and you've got to add your 30 degrees to it. And so the reference that we're talking about is 210 degrees as long as we're only going around the circle once. Okay, there you go. I'm going to stop this and upload it, and then I'll come back and show you what the assignment is. Actually, I can probably just show you. I'll just tell you right now, and I'll show you where it is in your packet in just a second. So let me get to the page. Let me show you what it is that you have to do. This particular lesson is a little longer. There are 2 parts to it, 3.1 and 3.2, just because we changed packets. So once you get this packet that's scanned 3.1 out of the new packet, you will see at the bottom of the page I have noted, not page, you'll see that I have noted the sections. So they are listed by section now. So you'll see section 3.1, and we're going to do 1 to 73, every other odd. Okay, and when I finish the next lesson, I'll scroll all the way down and show you where both of those are. You will have, as soon as I do the next set of notes, you'll have section 3.2, and that'll be the same thing, 1 to 73, every other odd. So they're at the back of the packet. You'll be able to see those there, and I'll scroll to them and show you as soon as I finish the next set of notes. Okay? All right, everyone. Signing off for now. Gonna upload this one, and then I'll be back in just a few minutes to do the next one.